Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers distance speed time. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 3. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. Okay, we've got a little stumpy graph here. Work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. Now, speed can be found by looking at the gradient of a distance time graph. Okay, because speed is the rate of change of distance with respect to time. So if I can find the gradient of that line, I should know what the speed is. Okay, so just going to kind of get a ruler out, just draw a little triangle here. Okay, and then we're going to look at change in y divided by change in x. Okay, so change in y, the difference between the y coordinates is going from 20 down to 0. So that's a distance of 20, isn't it? And then the change in x, I've got from 10 o'clock to 10:15. Okay, now presumably this is in kilometers per hour. We need to do it in. Yes, so I'm not going to write, rather than writing 15 minutes, I'm going to convert that into a quarter of an hour then. So a quarter of an hour. Okay, that's the same thing as 15 minutes, isn't it? So then the speed then is going to be change in y, which is 20, divided by change in x, which is a quarter in hours, a quarter of an hour. But if you think about it, dividing by a quarter is the same thing using keep change flip as times in by 4, which is going to be 80 then, isn't it? 80 what? 80 kilometers per hour. Part B says at 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. On the grid, complete the travel graph for Sam's journey. Okay, so he's stopping for 10 minutes. So if he's stopping for 10 minutes, he's not moving anywhere, is he? Okay, so for this section then, it's going to be flat for 10 minutes. So from 10:15 through to 10:25 then, he isn't going anywhere. So I'm just going to draw a kind of flat line between there and there. Okay, and then maybe I'll do it in green so it stands out a little bit more. Let's just try that again. Does that stand out a bit more? Hope so. So yeah, from 10:15 to 10:25 he's standing still, and then for 20 minutes after that, which will take me to 10:45 then, he is going to be traveling at 75 kilometers per hour. Okay, so how steep is that going to be then? It's a bit hard to use the gradient of 75 here because the graph doesn't go up that long and we haven't got hours on there anyway. I suppose we could scale the gradient down a little bit, but I think probably the easiest way of doing it is just do a quick distance speed time calculation, DST. So using the DST triangle, let's just work out how much distance he can travel in 20 minutes. Okay, so distance is what we're trying to find. Speed we know is 75 kilometers per hour, and time is 20 minutes, which is 1/3 of an hour, isn't it? Okay, so then distance, cover up what I want to, so distance is what I'm trying to find, so cover up D, so that tells me what to do with the other two. It's speed times time. So distance equals speed times time, which is 75 times a third, or in other words, 75 divided by 3, isn't it? So that is 25 kilometers then. Okay, so I know then in 20 minutes he's going to go 25 kilometers. So I can come along to 10:45, which is 20 minutes later, and I'm just going to go up 25 kilometers up my scale. So I'm currently at 20, so if I add on 25, that's going to take me up to 45. So I'm going to have a point then here, which is at 10:45 at a height of 45, and I'm just going to then join that up with a straight line. Okay, so then that's my completed travel graph then. Question 6. A ship is sailing in a straight line from its home port. The distance time graph shows 4 hours of the journey. And we've got the distance from the port up the side here, and that's in miles. And we've got the time along the bottom, and that apparently is in hours. Okay, and now we're asked to work out the speed of the ship during these 4 hours. Now, you hopefully remember the relationship between distance, speed, and time. If you don't, this handy triangle is quite useful. DST triangle. You notice they're in alphabetical order. DS and then T. And then you can cover up the thing that you want to find and work out the formula using the other two parts. So work out the speed of the ship during these 4 hours. So we want the speed, which is this one here. So we cover up the S, and that tells me what to do with the others. So average speed is distance traveled divided by time taken. Okay, so how much distance is traveled? Well, the distance traveled is, let's just triangulate a little bit so we can see what's going on a bit more clearly. So I'm just going to draw a triangle along here, up here. So then the distance travelled is this distance between here and here then, isn't it? So how far is it from there to there? Well, the top value is here. I've got 5 little squares between 100 and 120. So 20 divided by 5 is 4. So each one of those little squares is going to be 4 then, isn't it? So that top mark there is at 116. And the bottom one down here is 2 little squares up from 40. So if each one of those is 4, that's going to be 48. So then the distance travelled is going to be 116 subtract 48. What's that then? 52, 62, 68, isn't it? That's 68. And the time travelled then is this distance along here. That's a lot easier to work out. That's 4. Okay, so we travelled 68 miles in 4 hours. So if we divide one by the other, we should get the answer in miles per hour then, shouldn't we? So 68 divided by 4. 4's into 40 go 10 times. So 4's into 60 go 15 times plus another 2. That's 17, isn't it? So 68 divided by 4 is 17. Okay, so then that is 17 miles per hour. That's my final answer. Question 8. Lily goes on a car journey. For the first 30 minutes of her journey, the average speed is 40 miles per hour. She then stops for 15 minutes, and she then completes the journey at an average speed of 60 miles per hour. The total journey time is 1 hour. Okay, so let's just quickly sketch, before we draw the graph properly, let's just quickly sketch out what we're expecting. So she's going to start at 0, 0, and she's going to travel for 30 minutes at an average speed of 40 miles an hour. Now, that should be a straight line section then, shouldn't it? Which takes us up to, well, we're going to have to work out what that height is here, aren't we? And then what happens, she's going to be stationary for 15 minutes, and then she's going to continue on her journey at 60 miles an hour. So we're expecting
a steeper section of the graph up here that terminates at a time 60. So that one was 15 minutes. So that's at 45, isn't it? Okay, so what do we need to do? We need to work out that height for where she'll be after the first 30 minutes, and we'll also have to work out that height there then, where she's going to be after 60 minutes. Okay, so let's do that then. So for the first 30 minutes, her average speed is 40 miles per hour. So if she can do 40 miles in 1 hour, then in half an hour, she's going to be able to manage half that distance, isn't she? So at a time of 30 minutes, she will have traveled 20 miles. So I'm going to plot 2 points straight away. I'm going to plot 0, 0. And at 30 minutes, she's going to be at a distance of 20 miles. So I'm going to have a point there. She's then going to be stationary for 15 minutes. So I'm going to have a flat line between that point and that point there. And then she's going to be traveling at 60 miles an hour for the next 15 minutes. So if she can do 60 miles an hour, then 15 minutes is a quarter of an hour. So she can go quarter of that distance in 15 minutes. So a quarter of 60, half and half again is 15. So she's going to do 15 miles in 15 minutes. So if she's at a distance of 20 and she travels for 15 miles, she's going to now be at a distance of 35. So I'm going to plot a point at 60, 35. Okay, so now I just need to join those all up with straight lines. Done. Okay, so my graph looks like that. Write down the average speed for the total journey. Okay, now you remember from your DST triangle that if I want to find speed, then speed is going to be equal to distance traveled divided by time taken. So we know that she traveled for an hour, so that's going to be 1. That's going to make our dividing very easy. So how much distance did she travel then? So she started at 0 and ended up at 35. So she's traveled a total distance of 35 miles in 1 hour, giving her an average speed for the entire journey of 35 miles per hour.
Question 8. Chris visits a library. He cycles to the library in half an hour at a speed of 12 miles per hour. He stays at the library for 1 hour. He cycles home. The sketch represents his visit. Now this is a distance-time graph, isn't it? Because we've got distance on the y-axis and time on the x-axis. Work out the speed in miles per hour at which Chris cycles home. Okay. Right, so average speed is equal to distance travelled divided by time taken, isn't it? So speed equals distance travelled over time taken. Okay, how much distance did he travel in his journey home? Okay, so the distance he travelled, well, it's not on the scale, is it? Okay, what we want to know is that distance there, but it isn't marked. Okay, so it's not quite as straightforward as initially it looks, because we need to find what the distance travelled is first. But we've been given the speed of his outward journey, and we can see that his outward journey took half an hour or 30 minutes. Okay, so we're going to actually do this in two goes then. So we're going to have to use speed, distance, time to find the distance travelled he originally went, and then we use that in our second calculation. So the DST triangle kind of helps us rearrange this formula. So first off, we want to know the distance. So if we cover up the thing we want to find, the D, it tells us what to do with the other two. We're going to multiply them together. So distance travelled equals speed times time. So we're told it goes at 12 miles an hour. So 12 and we know it takes him half an hour. I'm just going to write that as 0.5 for half an hour. So 12 times a half, that's 6, isn't it? So that's going to be 6 miles. Okay, so now we know it's that's 6, so we can then move on to the second calculation to work out his speed on the way home. We know that he's traveling 6 miles. How long did it take him on the way home? You can see on the way home he set off at 10:30 and came home at 11:15, which is what, 45 minutes, which as a fraction of an hour is 3/4 of an hour. So 6 divided by 3/4 or 0.75. Either way, you can just type that into your calculator and come up with the answer. 6 divided by 3/4 or 0.75 comes out to be 8. So 8 what? He travelled 8 miles. The distance was in miles and the time was in hours. So that's 8 miles per hour.
Question 8 gives us a distance time graph showing the journey of a toy train. And underneath we have 4 possible descriptions of the first 2 parts of the journey. Now let's have a look at the first 2 parts of the journey. This first part here is a straight line, and it is increasing as time increases, so it's sloping upwards. So that indicates that the toy is moving at a constant speed. And then the next part, the distance isn't changing for a period of time, so that would indicate that the toy train is at rest. So which one of the descriptions most accurately displays that? So it must be B, moves at a constant speed and then is stationary. Okay, for part B, it says work out the average speed for the last 4 seconds of the journey. So average speed, if you remember your DST triangle, average speed is equal to distance travelled divided by time taken. And from our diagram, the last 4 seconds is this part of the graph. Well, we know the time. The time is the 4 seconds. So this is how much time it takes, 4 seconds. And the distance travelled then is going to be the distance from 4 to 10, which is a distance of 6 meters. So it's gone 6 meters in 4 seconds. So then average speed then is going to be our 6 divided by 4, which is 3/2 meters per second. Question 9 concerns itself with this distance time graph. Now this is showing a race between 3 boys, Alan, Ben and Carl, over 1,000 meters. So we've got the time along the bottom and we've got the distance along the side. Okay, so normally who wins the race is the person who gets to the finish line first. So we should be looking at which of these 3 boys gets to the 1,000-meter mark before the others. So the 1,000-meter mark is here, this line. So I'll quickly draw that on. This is the finish line here. So you can see that Ben reaches it here, and then Alan and Carl reach it at the same time here. So the person who gets there first is Ben. He gets there at this point here at 4.5 minutes. So who won the race? Ben. So Ben won the race. Why? Because Ben finished after 4.5 minutes and Alan and Carl finished after 5 minutes. Okay, Now the next part of the question asks us to describe the race, and it's worth 4 marks, so we need to come up with at least 4 statements about the graph. So we can read this graph from left to right, so you can see that as we start off, that Alan starts off the fastest, so Alan is in the lead, then Ben is second and Carl is third for the first part of the race. At this point, at 2.5 minutes, Ben slows down. At 3 minutes, Alan stops for a while and then starts again soon after at a slower pace. At 3.5 minutes, Ben speeds up and then overtakes Alan. Carl speeds up at 4 minutes, but it's not enough to overtake anybody, but he does finish the race at the same time as Alan. So, writing all that down in the question paper, at the start of the race, Alan is fastest. After 2.5 minutes, Ben slows down. After 3 minutes, Alan stops. After 3.25 minutes, Alan starts again, but slower than before. After 3.5 minutes, Ben speeds up. After 4 minutes, Carl speeds up. After 4.25 minutes, Ben overtakes Alan. After 4.5 minutes, Ben finishes. And after 5 minutes, Alan and Carl finish. So you can see I've written all those down just in chronological order, making a note of any changes along the way.
Question 16. The graph shows the distance travelled by a particle over the first 20 seconds of its motion. Show that the average speed of the particle over the first 20 seconds of its motion is 1.8 meters per second. Okay. So average speed. Do you know the DST triangle? DST. Okay. Distance, speed, time. Average speed, the S part of it is distance travelled over time taken. Okay, so average speed over the whole journey of this object is going to be the total distance travelled divided by the total time taken. Now obviously it starts off going quite fast and then slows down, but on average it has travelled a distance of, what's that at the top there, is that exactly 35? No, it's the square above 35. It's 36, isn't it? So it's travelled 36 meters in 20 seconds. So then the average speed is going to be the 36 meters it's travelled in the 20 seconds that it took. So what's that? Dividing by 2 is 18. So it's going to be 1.8, I guess. So that's 1.8. Okay, so the average speed is 1.8 what, meters per second? Yeah, we've done it there. So show that it's 1.8, we showed it's 1.8. I suppose we could just put the unit on the end to really show it. Okay, and then the second part says, estimate the speed of the particle at 10 seconds. You must show your work to support your estimate. Okay, so where is 10 seconds? So if you read up to the graph at 10, just reading up from there. We're talking about this point on the curve here then, isn't it? What is the speed at that point there? Now the way to work out the speed from a distance time graph is the gradient, isn't it? We want to know the gradient at that point. Now this is a curving line, so we can't just take 2 points and do change in y over change in x, because it only works for straight lines. For this one, because it's a curve, we have to estimate it by drawing on a tangent first. So a tangent is a straight line just touching the curve at that point of contact. I'm going to just draw that on my graph. I don't know if you notice, I kind of tried to make this either side of it about the same distance from the line. Anyway, kind of drawn that on. So that's my tangent. So then to work out the gradient, I'm just going to take 2 points that are easy to read. So I'm going to take, it goes off the top of the graph at over there. Why don't well, I'm going to take the point itself. That might be the easiest thing to do because that's a nice easy point to read. So I'm going to take this point here, and I'm going to take this point down here as my two values that I'm going to work out the change in y and the change in x for then. Okay, so how far is it from there to there? I'll make a little triangle here. So that distance, look, that one's easy to work out because it's just 10. That's the time that we took. So that distance is 10, and then the change in y, it goes from 30 to 18, so that's 12 in that direction, isn't it? So my estimate for the speed at that point is going to be the gradient, which is change in y over change in x, which is 12 over 10, which is 1.2 then, isn't it? So that's 1.2 meters per second at that point. Question 19. The graph shows the distance travelled by a particle over 8 seconds. And we've been asked to estimate the speed of the particle at 5 seconds. Now this is a distance-time graph, isn't it? So the speed is the gradient of the graph. Okay, so basically what we need to do is we need to find the gradient of the graph at a time t is equal to 5. So at this point here, how steep is this graph at this point? Okay, well clearly it's a curve, not a line. So to find the gradient of a curve like this, what we do is we draw on the tangent at that point by just kind of pushing our ruler up against the curve, so it kind of just touches, and you've kind of got the same amount of space either side here. Okay, so it's not an exact science, but you kind of just do it by eye as best you can and draw on that line. Okay, so there's my one there. And then what we need to do now is just find the gradient of our drawn line. So how do we do that? Well, we just look at change in y and change in x then, don't we? So change in y is that length there. That's quite easy to read. That's my numbers on here have gone a bit wonky. So that's 1, 2, 3 units, isn't it? So that's got a distance of 3. And then along here, I've got about 2.4 seconds this way. Okay, so then the speed equals the gradient, which is equal to change in y 3 divided by change in x 2.4. What does that come out to be? 3 divided by 2.4, 5/4. That's 1.25. 1.25 watt. Time was in seconds. So and distance was in meters. I divided meters by seconds. I've got meters per second then, haven't I? Okay, so that's 1.25 meters per second. So now don't worry if your speed is a little bit more, a little bit less than this. It's really going to depend on how you've drawn your tangent on. Okay, so you'll definitely get the same height as me as 3, but your length along here is going to depend on how you drew your tangent. So there's going to be a bit of variation in the answer, but as long as you use your distance in your calculation, then you're going to get the answer right. Okay, and we're done. Question 19. The graph shows the height above ground of a toy rocket for 10 seconds. Part A says, for how long is the rocket in the air? Circle your answer. Okay, well the rocket is in the air when the height in meters is above 0, isn't it? And that is for this time here. Okay, so between 4 and 10 seconds. So 10 subtract 4, That's 6, isn't it? So I believe it is in the air for 6 seconds. Now part B says, using the graph, estimate the speed of the rocket after 6 seconds. State the units of your answer. Okay, so after 6 seconds, this is the point on the graph for t is equal to 6, isn't it? Okay. Now, it's a curved graph at this point. Now, generally, if you've got a distance-time graph and you want the speed, then you need to find the gradient of the line, isn't it? So speed is equal to gradient of dt graph, distance-time graph. Okay, so the gradient of this distance-time graph will give you the speed, but we have got a curve, and finding the gradient of the curve is a little bit more tricky than the gradient of a straight line. So what we need to do first up is to draw a tangent to our curve. So if you take a ruler and you just kind of nudge it up against the curve so it just touches the curve at the point you're interested in, which I already marked on the diagram. Now that is what we call a tangent to the curve. Okay, we're going to draw that on. So that's my tangent. So then, because I haven't got a straight line, I'm going to work out the gradient of the tangent rather than the gradient of the line, because I haven't got a line. So what I'm going to do is I'm going to pick 2 points on that tangent that I can easily read. I think I'm going to pick this point down here at 2, 0. And I'm going to use change in y divided by change in x. So the speed is equal to the gradient of the dt graph, which is equal to the gradient of the tangent drawn at the point of contact. Change in y then, so change in y would be this height here. So we want that value, and we want change in x, don't we? We want this value here. Okay, so change in y, well that is 8, isn't it? The height of that bar there is 8. Change in x from 2 to 6 is 4. So then the gradient is going to be change in y divided by change in x, which is going to be 8 divided by 4. It's got a gradient of 2. Okay, so then the speed is equal to 2. 2 what? Well, the height's in meters and the time is in seconds, so the speed is in meters per second. So 2 meters per second. Now it does actually say state the units of your answer there, so that is actually worth a mark for getting that bit right. Okay, so don't forget that bit, meters per second. You can also write it as 2 meters per second to the -1. That's an alternative way of writing per second. Okay, because if you think about it, s to the -1 is 1 over s, so it'd be m over s. Same as before. Part B says the graph shows the distance travelled by a particle over 6 seconds. Now this is a distance-time graph this time, and we need to work out the average speed of the particle between 2 and 4 seconds. Okay, well let's look at our graph. 2 is here, 4 is here. So the average speed is distance travelled divided by time taken. Now distance travelled is going to be this. That's the distance travelled, and the time taken is this. Okay, so the distance travelled then is the difference between whatever that value is up there. What's that? That is, looks like my numbers have gone a bit wonky here as well. Okay, so then that is going to be 24 minus, what's that, 6? What's 24 minus 6? That is going to be 18. And then time is 4 take away 2, which is 2. So then average speed is going to be 18 divided by 2, which is 9. What's the units? Meters per second. And then part 2 says estimate the speed of the particle at 4 seconds. Now, if I want to estimate the speed at that point, it's a curved graph. So if I want to estimate the speed is the gradient of the line, but it's curving. So I need to draw a tangent at that point there and use that as an estimate of the gradient at that point. So drawing on my tangent. Okay. And then I need to take 2 points that I can easily read and divide one by the other to come up with an estimate. Well, we already knew that one was at 24, so let's crack on from there. So if I draw another triangle here, and work out the gradient of my tangent then. Okay, so then this line here, that top line is at 47. So the length of this line is going to be 47 minus 24 then. What's that? That's going to be 23. And this distance is 6 minus 4, which is 2. Okay, so I'm going to estimate the speed to be distance traveled 23 over time taken 2. I'm going to estimate that as 23 over 2, which is what? That's 11.5 meters per second. Remember, this is an estimate, and I might have got the angle of my line slightly wrong. It could have drawn it slightly steeper or slightly shallower. You will get a bit of leeway with this sort of question. So probably anything from like 11 up to 13 is going to be acceptable here, really. So don't worry if yours is slightly different from mine. As long as you found the gradient of your tangent, it should all be fine. Question 24. A ball is thrown from a point 6 meters above the ground. The graph shows the height of a ball above the ground in meters. Now, 6 meters is probably about roof height of a house. So imagine you're standing on the roof and you throw a ball off the roof. The first part of the journey, the ball is going to go upwards, but then due to gravity, it starts then falling to the ground and it hits the house, hits the floor a fair distance from the house, something like that. Okay, what we need to do though is estimate the speed of the ball in meters per second after 1 second. Okay, now after 1 second, the ball is at this point on the curve, isn't it? Okay. Now, we've got a distance and time graph here, essentially. It says height, but it's actually distance from the ground, isn't it? So our speed is going to be equivalent to the gradient of the distance-time graph at that point. So what we want to do, because this is a curve and not a straight line, is to draw a tangent on it with our ruler. So you just kind of put your ruler on the curve, so it's so it's just touching the curve, and you've kind of got equal space either side of it, kind of here and here between the line and your curve. So once you're happy with where your tangent lies, you can draw it on. Okay, it's going to look something a bit like that. And we're going to need to take 2 points on it and evaluate the change in y and the change in x. Now, I would suggest you take a point which lies on one of your known grid references. So I'm going to take this point here that is exactly at 2, and this point here which is exactly at 0. So I'm taking a good length of the line, and so I can be quite accurate. Don't want to put your points too close together. So that's going to be my change in y, and then my change in x is here. So how far is, well, my change in x is easy to do. It's just 2 subtract 0, isn't it? I'm going to quickly do that first. That's 2. What's my change in y? That's a little bit more tricky to read. So that point there, I think, is 2 little squares above 9. Now there are 5 divisions between each unit, so each one must be worth 0.2. So I reckon that point up there must be 9.4. The base of the bottom point of my y line is halfway between 6 and 7. I'm saying that's going to be 6.5. So then the change in y is going to be 9.4 subtract 6.5, which is 2.9. Okay, so then the gradient. So the speed of my ball is going to be equal to the gradient, which is change in y divided by change in x, which was 2 subtract 0 on the bottom and 9.4 minus 6.5 on the top, which was 2.9 over 2, which gives me 1.45. Now, the height was in meters and the time was in seconds, so this must be meters per second. 1.45.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.